Welcome everyone to geometry. We want to take a look at section 4 today, which is quadrilaterals. And a quadrilateral or quadrangle is simply a four-sided polygon. So we saw that in the previous section. But there are seven main types of quadrilaterals given here in this figure. So there is the parallelogram, the trapezoid, kite, isosceles trapezoid, square, rectangle, and rhombus. So I think that we're familiar with these. We're going to look at their slightly more precise definitions, but these give us an idea of what they look like, bring back some memories for us. And what we want to do is we want to learn a little bit about these shapes. So some of these things you might already know, others we will investigate. So the first thing we want to do is this computer exploration using GeoGebra. And in order to do that, we need a GeoGebra file. So a couple things that we'll need to do. First, we'll need to obtain the GeoGebra file. This can be done on Blackboard. I have posted it under the Content tab. And if we go to Part 1, which is where we're currently at, I've added a file called GeoGebra Files. And here we have, or I've added a folder called GeoGebra Files, and here we have Quadrilateral Exploration. Now when you click on this, it's going to open up a new tab and then download. So where it downloads is up to you. Some of you already have your computer set up, so that way it just automatically downloads to the download download folder of your computer. So you'll notice here I have downloads. So some of you may not get this pop-up screen at all because you haven't asked your web browser to ask you where you want to save things. So likely most of you will have it just go to downloads. So make sure you know where your computer is saving things when you download them from the internet. That will help you quite a bit. So we can go ahead and close that tab. So once you have that downloaded, you can, wherever you've saved it, you'll want to move on to GeoGebra. And once you open up GeoGebra, that's geogebra.org, you can click on geometry, because that's what we're working with today. So click on geometry. And rather than us trying to create things, what we can do is over here on our menu, our drop-down menu, we can open a program. Now there's lots of options here. Of course, that's not what we downloaded. So we're going to go here on the right-hand side of the screen where there's a folder that will allow us to open a program on the computer, and wherever you have saved it, go to that associated place on your computer. And I opened this recently, so I'm already in the correct folder, allowing me to select the correct file, and I can open it. Excellent. So this is the file that we want to work with. Excellent. Let's go back to our lecture notes then. So we have a collection of properties. There are 16 properties here, and we want to determine which properties each of the parallelogram, trapezoid, kite, isosceles trapezoid, square, rectangle, and rhombus have, right? We want to determine which properties each of these shapes has. So for example, let's take a look at the parallelogram. Let's see, at least one pair of opposite sides are congruent. So what does it mean for sides to be congruent? That just means that they're the same length. So if we go to our GeoGebra worksheet here, then we have this that we can manipulate some of these vertices on. Excellent. And you'll notice that as we move these, we can see that this side and this side are parallel, and that's true no matter how we move each of the vertices. Okay, excellent. We also have that the left and the right side are parallel too, but for this property, at least one pair of opposite sides are congruent. We do have that the parallelogram has that property. All right. Both pairs of opposite sides are congruent. Well, is that the case? Let's return back. Oh, and I did that wrong. I wanted one pair of opposite sides are, the first property I think I did for parallel. At least one pair of opposite sides are parallel. I think that's what we discussed in there. I apologize about that. So that was down here. So I'm not sure the language that I used. Let me return back to that and make sure I'm stating the correct thing. For the parallelogram, as we move these vertices, we can see that in fact the opposite sides are parallel. So it does satisfy the property, that property, but also these sides appear to be the same length. The opposite sides appear to be the same length, and is true for both pairs as well, right? Opposite sides, top and bottom, appear to be the same length, appear to be congruent. The left and right sides appear to be the same length. That is, they appear to be congruent as well. So it is true that parallelograms satisfy the first property, or they have the first property, one pair of congruent opposite sides, and one pair of parallel opposite sides. Excellent. So let's try to read these. I'll try to read these properly now. So both pairs of opposite sides are congruent. Excellent. Yes, congruent, both pairs. If we take a look, we can see the top and bottom are congruent. The left and right are congruent. So yes, we have that both pairs of opposite sides are congruent. Excellent. All right. At least one pair of opposite angles are congruent. All right. At least one pair of opposite angles are congruent. So opposite angles would be angle D and B here, as well as A and C. So are A and C, do they have the same angle measure? Yes, they do. At least they appear to have the same. And we can move these, and that stays true. They still appear to be the same measure. Excellent. So you would say yes. And in fact, both pairs of opposite angles appear to be congruent all of the time. So if we return back here, at least one pair is, but in fact, both pairs of opposite angles are congruent. So it has properties 1 through 4. All right, now let's see, the diagonals are congruent. Is it necessarily true that the diagonals are congruent? Well, what are the diagonals? Let's take a look at that. So diagonals would be the line from D to B, and the line segment rather, from D to B, and the line segment from A to C. Do these appear to be the same length? If they're the same length, then they would be congruent. However, we can see that A and C are closer together than B and D. If we were to move this, we might be able to make it so that way they're the same. So around here they appear to be the same, but I can easily manipulate it to change that. So since I can manipulate it and change that, I would say that it does not have that property because it's not always true. So it does not have property 5, diagonals are congruent. Does it have the diagonals are perpendicular? Well, if we were to return back to this again, we could quite quickly see that we could make it so that way the diagonals, we could make them be perpendicular to one another. Right here, that might be the case, but as we move here, we've got a line that's quite sloped, but not at a 40. Well, yeah, so if we were to draw a line from A to C, a line from B to D, these would not create right angles. Excellent. So it does not have property 6, the diagonals are perpendicular. All right, now the diagonals bisect one another. So what does it mean to bisect? Well, what we mean by that is if we were to draw a line again from A to C and from B to D, would each of these line segments cut the other in half? So if we were to cut on the line from A to C, would that cut the line from B to D in half? And yes, it would. It would cut it in half. So we'd say, yeah, all right, diagonals bisect each other. And then at least one diagonal bisects the angles at the vertices. All right, at least one angle bisects the angles at the vertices. What do we mean by that? That means that if we have, again, draw a diagonal from A to C, does that cut this angle in half? Again, if we go like this, we see that a line from A to C would make this angle very small and this angle very large. So no, it would not bisect that one. Similarly at A, and then the same thing could happen as we change this. It would not necessarily, the line from D to B would not necessarily bisect angle B or angle D. All right, so it would not do that either. Let's see, we were at least one diagonal bisects. And no, both diagonals bisect. Definitely not. If one of them doesn't, then both of them. We can't say that both of them are going to do it. And then both pairs of opposite sides are parallel. Heck yes, they are. All right, we got one more here. We already talked about at least one pair of opposite sides are parallel, but we do have that both opposite sides are parallel, both pairs. All right, at least one diagonal is a line of reflection symmetry. So when I say that, is if I were again to draw the diagonal, if I were to reflect over that line, would it result in the same image? Of course, if I drew the line from C to A and reflected over that, then the labelings would change. B would move to the left and D would move to the right. But would I end up with the same image? Well, not necessarily, right? As we move this, D would end up being up here and B would be down here. We wouldn't have that B moves to where D is and that D moves to where B is. That's what the symmetry would be. So for example, if we wanted to understand that a little bit better, a square does have at least one line of symmetry using a diagonal. So if I drew a line from E to G and then reflected over that, H would go to where F is, F would go to where H is, and we would have a square that looks exactly the same, just the labeling's changed. So that would be a line of symmetry. But the parallelogram does not necessarily have that. So we said that the square does have that, but the parallelogram does not. So let's see here. Both diagonals are lines of reflection of symmetry. Does not have that. It doesn't have one, so it certainly doesn't have both. At least one pair of adjacent sides are congruent. And that's not necessarily the case here. So we talked about opposite sides being congruent for a parallelogram, but we don't have that adjacent sides. Side CB and side BA are not congruent. I could change them so that way they appear to be. They might be congruent now, but notice what we have here. Well, it looks a little bit more like a rhombus. So that's interesting, but it's not necessarily true. Here, clearly, CB is shorter than BA, so they're not congruent, and we could change the side lengths for each pair of sides, each pair of adjacent sides, to show that we would not necessarily have this property. All right, there are two separate pairs of congruent adjacent sides. No, there wasn't one pair, so there's certainly not going to be two. And then there is at least one interior right angle. So in a parallelogram, do we necessarily have any right angles? No, we don't, right? Not a right angle, not a right angle, not a right angle, not a right angle. So we don't have that property for parallelograms. So this is the collection of properties that the parallelogram has. Do the same thing for the remaining quadrilaterals and fill this in. If you have any questions, so fill in remaining. So I'll let you guys fill in the remaining. If you have any questions or would like me to check your solutions, feel free to have me do that during lecture or stop by during my office hours. But this is the exploration that I would like you guys to do. And that is going to be the end of our first video. So go ahead and finish this exploration and let me know if you have any questions. I'll see you guys again soon.